Today we're going to look at this pretty interesting looking problem. Integral between -1 and 1, root 1 minus x squared minus x over root 1 minus x squared, 1 plus x, root 1 minus x squared. So the first thing you'd probably think of when you see this is some sort of trig substitution might be a good idea. So go ahead and start, say x equals sine theta. Now dx would be cosine theta. And our new limits would be minus pi over 2 and pi over 2. So what do you have now? So we've got root 1 minus x squared on the top, which would be root 1 minus sine squared, which is just cosine theta. And that is sine theta. And the denominator, that square root 1 minus x squared is actually just cancelled from the dx. And we're just left with 1 plus sine theta cosine theta. So now this is our integral. Now, solving this, it's quite difficult to spot, but if you think about the sine double angle as that sum of cosine theta plus sine theta squared, then it becomes a bit more approachable. So I'll show you what I mean. First, I'm going to quickly write sine theta cos theta as the sine double angle. So minus pi over 2, pi over 2, cosine theta minus sine theta. And here we're going to say this is a half sine 2 theta. Now we're going to quickly take out the 2. So now we have 2 plus sine 2 theta on the bottom. Okay. Now quickly, I want to quickly write this 2 as 1 plus 1. And the reason why I'm going to do this is we can isolate 1 plus sine 2 theta. So first, if we want to just take a look at 1 plus sine 2 theta for a second, we can write this 1 here as cos squared theta plus sine squared theta. And then if we expand out sine 2 theta, we get 2 sine theta cos theta. And you can kind of see where this is going. We can write this as cos theta plus sine theta squared. And this actually works the other way around with a minus sign. So we can just say cos theta plus or minus sine theta squared equals 1 plus or minus sine theta. And this is true. So back to our problem up here. If we take this 1 plus sine theta and write this as cos theta plus sine theta squared, then we can make a nice substitution. So let's have a look. What do we have? We have cos theta minus sine theta on the top, and then we'll have 1 plus, and this would be cos theta plus sine theta squared. And interestingly, if you make a u substitution for cos theta plus sine theta, the derivative is just what's on the numerator. So we say u equals cos theta plus sine theta, we end up getting du equals cos theta minus sine theta d theta. So putting this in, our new limits would be, if we put in minus pi over 2 in the bottom, then we'll get minus 1. We put in pi over 2, we'll get 1. And this numerator goes away from the du, so just left with 1 on the top. Then we have 1 plus, and cos theta plus sine theta is now u. So we have 1 plus u squared on the bottom. And now this is fine, this is just an arctan integral, so we can evaluate this nice and easily. So this is arctan u between minus 1 and 1. Putting this in, we have 2 pi over 4 plus pi over 4, which gives the answer as pi. There you go.